This is my 1995 Camaro, and we are trying to make this thing into the fastest Vortec 4200 powered car that we have ever built on this channel. We're taking everything to the next level. Motor plates, bigger turbo, dual plenum intake, 8-speed transmission, and hopefully this will be one of the lightest cars that we have ever built. And our goal is to take it to Sick Week and compete in the Sick Week Freaks class. We won this class earlier in the year in our Pontiac Sunbird, but it's time to up the ante. So let's get to work. Alright guys, the first thing that we're going to work on today is the exhaust manifold. Now obviously this is not a header for a Vortec 4200. This is a header from a LS. I know, it's like my kryptonite or something, but I'm going to use this header for demonstration purposes. So with a header, your goal is to obviously collect the exhaust gases out of the engine and send them to wherever you want them to go. In this case, we want to send them into a turbocharger. But there's lots of different ways to make a header like this. So a header is composed of a couple of components. You got your header flange, you got your primaries, and you got your secondary pipe. And then in between the primaries and the secondary pipe is what is called the collector. And there's a couple key elements here to designing an exhaust manifold to perform and sound the way that you want it to. First off, you need to size your primary diameter to be the correct amount for the amount of power that you want to make. For our build, we decided to go with an 1 7/8 OD tube. And with this build, I wanted to take everything to the next level. So I decided that I would like to build an equal length rotationally timed header. Now, equal length refers to the length of each primary. This right here is not an equal length. You can see that this tube right here is not even close to the length of this tube right here. So with an equal length, you would likely see this tube here in the front make some sort of big swoop in order to match the length of the tube that has to travel the longest distance. But what length should you select? Well, there's actually a lot of calculators out there to determine what length the primary tube should be. And my dad has been using one for many years that he developed from a couple of resources that he found online. But the problem with this calculator is it is based on naturally aspirated. And in a naturally aspirated application, you're going to see different conditions than you would see on a boosted application, like what we're doing on the 4200. And the length of this primary tube is dictated by how the waves move down the primary tube and reverberate back up the primary tube. And the speed of those waves is dictated by the speed of sound of the gas inside of your header. Now, I would imagine that there is a gradient of temperatures as you move down the tube. I imagine the temperature's pretty hot up here, a little bit cooler down here. So I selected a temperature of 1000 degrees Fahrenheit for a naturally aspirated combination. And with a naturally aspirated combo, you should be seeing close to atmospheric pressure inside of your exhaust manifold. If you're seeing more than atmospheric pressure, you have a problem. And I basically asked my brother, who is specializes in thermodynamics, what the speed of sound at that condition was. Then I assumed that we were going to see higher EGTs with a boosted application. I assumed 1200 degrees Fahrenheit. And I assumed that the pressure inside of here would be around 40 to 50 psi G. And that gave me another speed of sound. And basically I was able to take that calculator that was designed for a naturally aspirated combination and use the speed of sound, or the difference in speed of sound, as sort of a scaling factor, and that gave me a different primary length. And I was a little surprised to see how little difference there was in the primary length, but this is what we use to determine what primary length we wanted to target on this build. Now, I've built quite a few headers, but my dad has built many, many more than I have ever built, and he is much better at getting the primary length to be pretty much dead on with every single tube. He can see the thing in his mind a lot better than I can. So I handed off the header design task to my dad, and he got to work. Alright, so Dad's been working on the header for the red car, and he almost has the third primary done, and I wanted to stop him here for a second and have him explain some of his thought process when making this exhaust manifold. So, I guess take it away.
Alright, well the first thing I always look at is bolt access, and then I always set the collector first. I want as much straight tube going into the collector as possible. And on this header, it's sequentially timed. So, 1, 5, 3, 6, 5, 2, 4. And we're working on 4. 2 I knew would be the most difficult. I set the length based on the easiest tube. I try and get the hardest tube and just build them from there. But the key on this is you got to be able to take it in and out of the car. You've got to be able to keep it away from the alternator, keep it away from the steering, keep it away from any of the metal structure, and have access to all the bolts. So making these things equal length primary tubes is very challenging, and then sequentially timing them is even that much more of a challenge. But here we are.
Yeah, and I guess if they look cool, that's always a plus too, right?
Well, they got to look good. Sometimes they can really look terrible to get the function you want, but that's why you tack them together and take them all apart if you don't like the look that you see, because you don't want something that looks like a total disaster.
Yeah.
It's hard enough to put these together and think about all of the different features that need to be maintained in order to have the quality that you want at the end of the day.
Yep.
But I think we're doing real good here. We started a little after lunch, and we're not even at dinner time yet, and we're working on the third tube. These would be the 3 hardest tubes, and then the ones that are further out are a little easier. There's a lot less bends that we have to put into them. 3 is going to be a headache because we got to shoot that up in between 2 and 4. I'm thinking we've got enough room here to do everything that we want.
Well, I'm excited to hear what they sound like. So
this ought to sound good. This is taking a lot of thought process, but I'm actually enjoying it.
Yep. Alright guys, here is what we ended up with. I am super happy with how this came out. This thing's pretty sweet. My dad was able to get the primary lengths to be within 11/16 of an inch of each other, and I am super excited to hear what this sounds like. But before we get to that, we need to talk about boost control. Alright guys, now that we have the header figured out, it's time to figure out our wastegate. And for that, we need to first find a location. And we have decided on right here. Now, the first thing that we had to do was we had to bore a hole into the pipe here and then place the wastegate. And when you're placing a wastegate, you really need to think about how the gas moves through the header. And you need to give it good priority so that you can control your compressor speed and turbine speed. Now, the goal of a wastegate is to bypass exhaust gases around the turbine and not increase the amount of energy that is going into the turbine and basically regulate the compressor speed. The problem is, if you place the wastegate in a bad location, this will run away because you're not able to vent the gas effectively. And for the venting of that said gas, we have something really cool to talk about as well. And that is this TurboSmart 50 millimeter straight gate. Now, TurboSmart came out with this wastegate a few years ago, and ever since it came out, I have been wanting to get my hands on one. The reason for that is this style of gate should work way better than any other style of wastegate that is on the market. It will flow a lot more, but there's a bunch of other hidden advantages with this thing that we're gonna get into right now. All right, guys, so let's talk about boost control. This right here is your standard poppet style of wastegate. Basically how this works is there is a valve here in the bottom and it opens and redirects gas out of the side. There is a diaphragm and there is a spring. The spring pushes down in this direction and the diaphragm is connected to this poppet style valve, and this just moves up and lets gas flow out of the side. Now, there is something called your spring pressure with this type of valve. Basically, the amount of air pressure that you apply to the bottom here to where the poppet valve starts to open is what is known as your spring pressure. So you'll hear people say like, oh, I have a 3 psi spring in the car or a 5 psi. Basically at 5 psi of air pressure, that is where the valve starts to move. Now, in order to get more boost from a valve like this, you need to start to apply air pressure to the top here. Now, what people do quite often is they either use a bleed valve or like a 3-port boost controller, and they take the air pressure from your turbo, which is normally being applied to the bottom, and they begin to apply it to the top. But you can only get so far with that, and that is because the pressure in the exhaust will begin to build because it kind of has to in order to drive the turbo, and it will push against this flat surface here and force the valve open by itself. The rule of thumb is you can normally get from your spring pressure to 3 times your spring pressure with a poppet style of valve and a 3-port boost controller. So if you had a 5 psi gate spring, you could be able to get to a 15 psi boost level before you would have to change your spring and, apply more force to the diaphragm and keep the valve shut. Now, it would be really advantageous to have a wider operating range on a lot of combos. And in order to do that on most people's cars, what they do is they install a CO2 system onto the car or some sort of onboard air system where they have a compressor and a reservoir for the pressure that kicks on and regulates and whatever. And then they have a series of valves that apply more pressure to the top of the wastegate and keep that thing shut. The problem with that is you got to remember to fill a bottle or turn a bottle on. And if you develop a leak anywhere between the bottle and this diaphragm here, it will lose all of the pressure in the bottle and then you have to fill it again. And there's just a whole series of issues that can arise from that type of system. So wouldn't it be cool if there was another way that you could fix this problem that didn't involve all that complicated nonsense? And that is what we have right here. Ever since TurboSmart came out with these wastegates on the market, I have wanted to get my hands on them. Now, a lot of other YouTubers have used these valves, and I think they're really missing the point for why this valve is so cool. This is one of their straight gates, and basically how it works is it has a butterfly style of valve instead of a poppet style valve. And instead of having a poppet that opens and closes like this. They have a valve that opens and closes like this. And with this type of arrangement, you no longer have that back pressure effect that will push the valve open by itself. To explain this concept, I'm going to use a throttle body just because it is another common component that uses a butterfly style of valve. Your throttle body is another example of something that you really wouldn't want to push open by itself. Obviously, it would be cool to be able to shut the throttle when you want to, but basically, when the pressure is flowing into this valve, there's an equal amount of pressure pushing onto the top as there is on the bottom. So there's pressure that's pushing here in the top that would want to open the valve, but there's also an equal amount of pressure pushing on the bottom that will close the valve. So you're never going to have like a runaway situation where this thing is going to get stuck open or anything dumb like that. So this is the ideal type of valve to use in a system where you need that type of control. And with the straight gate, you get that. So in theory, with this type of valve, you should be able to go from wherever your spring pressure is to basically an infinite amount of boost. The valve is never going to force itself open with back pressure, and you should be able to make any amount of boost that you want without having to employ CO2. Now, some of you might be out there and might be saying to yourself, okay, yeah, big deal. You got to remember to turn a bottle on. Like, what are you, like, stupid or something? Well, when you're on a drag and drive or just in any type of competition, it's a common problem. If you guys follow Cletus McFarland, he has a whole system in one of his new cars where it will turn on the dome light when he doesn't have his CO2 bottle turned on, and it will not turn off that dome light until he turns his CO2 bottle on, just to make sure that he remembers to turn the CO2 bottle on. So it's definitely a problem. Now, another thing that you may have heard other YouTubers talk about with this valve is that it flows better than your typical 50 millimeter wastegate. And yeah, it does. And that's very cool. But to me, the primary advantage for having a valve like this is the superior control without any of the extra nonsense. So that is why I have always wanted to get my hands on one of these. Brilliant design, and I'm super happy to be working with the guys over at TurboSmart. So with that out of the way, next we need to move on to the rear end of the car. We got to do a little bit of maintenance and some replacement of parts. So let's get on to it. All right, guys, we have a little bit of work to do here on the rear suspension, but in order to do that work, we need to drop the rear end housing out of this thing, and then we will get into some explanation of what we're going to upgrade / change and why. So let's get this thing pulled out. It's fine. Who cares? It's fine. Try to use the jack. Alright guys, now that we have the rear end taken out of the car, we can talk about why we needed to take it out of the car. So there's a couple of modifications that I want to make to this rear end housing that has to do with how the rear end housing applies force to the chassis. But before we get to that, we need to show something else that needs to be fixed. So this rear end here is a strange S60. It's based off of the Dana 60 architecture, but they have made their own custom casting that has the torque arm mounts for a 3rd or 4th gen Camaro. I think they've also done some work to lighten the things up. Dana 60s are kind of notorious for being excessively heavy. They're also notorious for being nearly impossible to break. They have a 9 3/4 inch ring gear, I think. So this is even stronger than like the infamous Ford 9-inch. But we have a problem with ours, and it is right here. If I try to spin this, it's really crunchy in there. It's clear that one of our pinion bearings has started to fail and needs to be replaced. I don't know if somebody tried to run this thing without oil, but yeah, we have problems there. Luckily, Strange sells all of the bearings that you need in order to service this axle housing, and I have purchased an entire kit from them, so we will be fixing that. But the next mod that I would like to do to this thing is I would like to change the lower control arm mounting points. So on the rear end side, we have this kit right here. This is from BMR Suspension. I think the discount code is still live. If you guys use NIVLAC7 at checkout, you should still be able to get a 7% discount on any parts that you buy from BMR. But they supplied this kit right here for us. Basically how this works is you install this down in this location, and it gives you 2 more pivot points here that you can install your lower control arm in, and you can change how the rear end housing loads the car. We'll get into that a little more later. But we're also going to make mods on the chassis side to aid in that as well. So let's go to that. Frankly, it's amazing that this car was being raced without the mods to the rear end housing. But here is something that came along in the last couple of years to help on the chassis side. Now on the rear end side, we have those 2 pivots that we're going to add. But on the chassis side, we can also add some pickup points as well. This kit is from Rock Solid Motorsports. It is 2 billet steel halves that are welded together. This is some really, really nice stuff. But basically what this will give us is it will give us some adjustment in the up and downward motion, so we can weld this in and cut out our old suspension pickup bracket here. This will allow us to really angle the trailing arm in whatever direction we would like to, and really dial in where we would like the instant center to be on the car. But why would you want to do this? Let's talk about it. Now, there are 2 main types of forces that your rear end housing will apply to the car. And how the rear end housing applies force to the car will dictate how the tire is loaded and also how much traction there is available. So the 2 main types of forces are wrapping forces. Basically, as this rotates, the pinion gear will try to climb the ring gear, and it will apply a wrapping force. Basically, this whole housing is going to try to wrap in the upward direction. And then the other type of force is tractive force. Basically, as the tire gets traction with the ground, it will apply a force that way, and then apply a force this way onto your axle bearing and therefore your entire axle housing. Now, if you guys have been around drag racing for any amount of time, you will have heard the term instant center. And instant center can be simplified to how the rear end housing applies force to the chassis. And of course, as it applies force to the chassis, there will be an equal and opposite force applied to the rear end housing, and that will dictate how the suspension moves and how the tire is loaded. So there's 3 different ways that the rear end can apply force to the car. And you can think of it as your rear end housing is getting in a fight with your car. Now your rear end housing can stomp on the chassis toes, it can kick it in the stomach, or or it can uppercut it in the face. And depending on how the rear end housing applies force to the chassis will dictate how much force is generated in the downward direction, which will dictate how much traction is available. Now, certain tires like different things. If you're running a big tire car, they like it when you stomp on the chassis toes. In this case, it causes the chassis to squat, and it will actually unload the tire. If you think about it, if the rear end housing is stomping on the chassis toes, you're taking load off of that as you stomp with your other foot. In the case of kicking them in the stomach, all of the force is applied in this direction. This would be like a response where it's neither separating nor squatting. And it would neither be loading or unloading your tire, and therefore you would not be adding or removing the amount of force to the tire. The last response is uppercut to the chin, and in this case, you are applying force in the upper direction, and you're lifting the chassis, which will put more force onto your feet or load the tire more. In the case of a drag radial, they normally like it when you uppercut the chassis in the face, and that is why we are doing the mods that we are doing to the rear end housing and to the chassis. This will allow us to apply the force more in the upward direction and allow us to put more force onto the tires since we plan to run a drag radial. Now, I'm definitely oversimplifying this a lot. I haven't really talked about leverage. As you shorten the instant center, you will have more leverage on the chassis, but this is more of just explaining to you guys why we're making the changes that we are making and, you know, kind of how they impact the car. So now that I've explained what we are doing, let's get to work on making these modifications. Alright guys, so how this kit works is it basically goes up in here and it gives you 2 more adjustment holes in the vertical direction. Now I'm not sure why you would want these 2 lower holes, but it gives you that option as well. But basically what we have to do is we have to cut this outer suspension mount out, and then we will run a bolt in on this side to locate the piece where it needs to be welded in. I did notice that, I don't know if my frame is slightly tweaked or if when they welded the tub in, they had to do something weird there, but this corner here is not allowing this to go in 100% straight. It has to kind of go in there crooked. So I'm gonna have to figure something out there. I don't know if I'm gonna take like a dull chisel and just hammer this part of the frame up and out of the way, or exactly what I'm going to do. Once we have this sort of located in there, we will then weld all of the seams that are available to us, and then we will plate in the rest of the suspension mount. So this is a super nice kit. Definitely an ideal setup for guys who are looking to run a radial on a 3rd or 4th gen Camaro. So let's get this thing figured out and weld it in here. rather than fighting with this curve here, which I'm still gonna have to fight with a little bit, I decided to just weld this 1/4-inch plate on here. I tried to make it as light as possible by drilling a hole in there and kind of rosette welding it. But now this piece fits up in a whole lot nicer into the suspension mount here. It's okay if it's shifted over a tiny bit. That's not going to hurt anything other than slightly less tire clearance. But I think we'll be all right there. So now I just need to pound this up out of the way a tiny bit more, and then we can get the Rock Solid Motorsports kit installed. So the tick from Rock Solid Motorsports comes with this little plate. You're meant to weld it in here and box it into the original suspension mount. But I decided to make this little plate here that ties it into the rocker. I will weld it on the back side here where the original suspension mount is. And whoever built this car did a really nice job of tying the sill bar part of the 25.5 cage into this portion of the suspension mount. So I will weld all of that back in, and we should be able to have a really nice, robust package right here. So let's get this welded up. What I ended up with. I tied it into the sill panel right there. This metal out here was really dirty and hard to weld to, so I just did the best that I could. Then I welded it in underneath, and I think it came out pretty good. I got some color match paint to match the body, so now we just need to do the other side, and this should give us all the suspension adjustment that we need. All right, guys, I hope you guys enjoyed today's video. I hope that you learned something somewhere along the way. I am really excited to get this car done, and I'm really happy how it is coming out. But we have a ton of work to get done on this yet. We still have to put together an 8HP 70 for this car. We got to finish up the turbo plumbing, get this thing wired, get this thing plumbed, get this thing, actually functional. And frankly, this is my least favorite part of the project. Everything is everywhere, but we are making progress. If you enjoyed today's video, make sure that you go share it with one of your friends. Like, comment, and subscribe. And by the way, hit the hype button. Apparently that's a new thing for us YouTubers that are under 500,000 subscribers. It's down below. Sometimes it shows up, sometimes it doesn't show up. It doesn't show up for me. But anyways, yeah, hit the hype button, and Merry Christmas and Happy New Year to all of you guys out there. Me and my family are so blessed and thankful to have such amazing fans. So big thanks to you guys out there, and thanks to everybody that came and said hi at PRI. That was really cool. All right, see you guys this sick week.